Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode in the Chai Time Data Science Show. Also, the second episode in the Transformer/NLP release series. In the previous interview, I interviewed Andrew Shaw, creator of Music Autobot, which is an AI-powered pop music generator. You should definitely check out the episode if you haven't. In this episode, I interview another one of not just mine, but I believe also machine learning hero to many people, the CTO of Hugging Face, Julien Chaumond. We talk about his journey into the field and his path as a CTO of Hugging Face. Hugging Face has been doing some very amazing work that I'm pretty sure everyone is familiar with. And I try to discuss all of these open source and research aspects being done at Hugging Face, including the live Transformer demo in the browser, the demo of the Conversational AI, co-reference research, and the demo, which also is available for you all to check out. The open source library and the implementations of transformers. Note that this was before the release of the TensorFlow ported version of transformers. So unfortunately, we don't have the discussion about TensorFlow in this interview. We talk, of course, all about the PiThoughts side of things and things on the iOS world as well. Hugging Face also has shipped models onto iOS devices, which we cover in this interview. I'm really excited to share this interview, and I hope you really enjoy the conversation. I'm really excited to have Julien on the podcast. Thank you so much for joining me today, Julien.
Hi, Sanyam. How are you?
I'm great. Thanks for doing this, and thanks for joining me.
Thanks for having me. Yeah, it's a pleasure.
It's an honor. I'm a huge fan of things being done at Hugging Face. I've actually generated an intro of your profile. We will have one official one recorded, but using your website. So if I may read it out.
Yeah.
So the queue, so to people who don't know, go to transformer.huggingface.com. You can generate text over there using a transformer model. You can give a queue. I gave the queue. Julien is the CTO of Hugging Face. And this is what the model generated. He has written many books on the subject of hugs, including Hugging Your Face and Hugging Yourself. He likes to read papers, blog, and other interesting things. You can reach to him on Twitter. And then there's a Twitter handle and your email. So what are your thoughts on that?
Yeah, that's a pretty good description. Yeah. So basically, I've been amazed with GPT-2 shipped by OpenAI less than a year ago, actually. So it's pretty recent. And I think it's been like really impressive. So we've taken the models, ported them to PyTorch, and then packaged them into like a nice demo application, web app.
Right.
And yeah, it's really, really cool. Like people have been using it for a lot of like super interesting things. Yeah. And yeah, it's really great. It's really great. I should point out that it's huggingface.co, not .com, just so that people can find it more easily.
Yep. I'll have the correct link in the description for people who want to check it out. Before we talk all about the open source projects, could you tell us more about the work being done at Hugging Face, and could you tell what is the product by the company?
Yeah, definitely. So we started the company with my co-founder Clement 3 years ago today. We were super interested in NLP. From the start, and we were thinking that NLP was going to be like a super big subfield of AI. Basically, we've always been like kind of passionate with text processing, even like before the deep learning techniques were widespread. So we were like super interested in NLP.
Right.
We wanted to dive into NLP, but also to try and find a consumer usage that would be different from what the other big tech companies were doing. So we started by focusing on more entertainment oriented vision of conversational AI.
Right.
So our first product was like a fun conversational AI. Basically like an AI that you could talk with and have fun with and kind of become friend with over time. So we worked on that product for a couple of years, and we've had like a lot of usage. Like a big number of monthly active users, daily active users are using the app.
I think the number is up in a few 100,000, if I know correctly.
Yeah, exactly. Yeah.
That's amazing.
Yeah. So yeah, basically like 500,000 monthly active users.
Wow.
And it's been growing ever since. What we realized, however, over the last couple of months is that it's really hard to do a really good conversational AI.
Yeah.
So that was like one of the big learnings of these first years of working on Hugging Face, was that the tech and the science simply isn't there yet to do a super impressive version of conversational AI, which is something that we have in our mind. Like the long-term goal for us is to be able to build a conversational AI that's going to basically assist you and kind of like replace the usage for you of Google, Facebook with something that will be like way more fluid and way more efficient. So basically our vision of a conversational AI is going to be really impressive and useful for
almost
a lot of
like
people.
A real human.
Yeah, almost. Yeah. Or even like better at certain tasks than a human. So we don't want to replace humans. We like humans.
Yeah.
But basically we think that we really believe that AI and conversational AI are going to enable usages that are going to be like so efficient and transformative for the stuff that we're doing. So anyways, we think that there is still a lot of things to do on the science and the tech side before being able to ship something like that. So we've kind of taken a step back and decided to focus even more on the science and tech side for a few years.
Yeah.
Also because we've seen, and we can probably speak about it later, but we've seen that we've been able to achieve some breakthroughs on the science side as well. So yeah, for now we want to really dive into the science, push the state of the art, and do great things on NLP.
Got it. We'll definitely talk a lot about the research side, the science side of things that you've been pushing. But for context, when you started working on this problem, now we have transformers, we have these BERT models that look like human generated text. But back in the day, and what were you even thinking that this challenge would be solvable to this extent, like it is in 2019, for example?
I mean, we were kind of like already in like 2016 when we started the company, we were seeing that a lot of things were happening in NLP. So basically 2016 was the year of like neural based conversation. So the first systems that were using like deep learning networks to do automated conversations. at that time it was mostly like RNNs, LSTMs that were powering conversation systems. It didn't work super well in terms of like quality of conversation, obviously, but it was still pretty impressive that you could try and apply like end-to-end deep learning techniques to do something that was traditionally done with a lot of like hand coding and rules.
Got it.
So that's on the conversation part, and even on like more globally like NLP tasks, we were seeing that a lot of things were happening, and so we were kind of thinking that it was going to continue. But we've been surprised, obviously, with the growth that we've seen in the field. Like a lot of people doing incredible things in the field, and basically the past couple of years we've seen like an acceleration of breakthroughs in NLP, which is like super exciting.
Yeah. Now to talk a bit more about the founding team, I think I saw an interview with Clement, who's the CEO of Hugging Face, who mentioned that you were earlier working on rival companies for a few years, and then you decided to start a venture together. So how did you decide to work with him, and what made you pick him as a co-founder? Because usually, like personally, I would imagine I cannot work or even talk to a person who's building a rival company.
Yeah. So we met close to 10 years ago in Paris, France. We were working on kind of like maybe not concurrent, but like not competitive, but mostly like startup companies in the same space. Okay. And we kind of like became friends at that point. Mm-hmm. And then we both did other startups or other projects over a couple of years, but we stayed in touch. And then, basically in 2015, we were both like super interested in machine learning and NLP. Clement used to work at a machine learning company that was acquired by Google a couple of years back. And I was diving into machine learning again. So we were both like super interested in the same subjects. But most of all, we kind of always knew that we wanted to start a project together because we felt like it would be a good fit, like a good personal fit. So mostly like personal fit and kind of like a desire to try to work together and see what happens mostly.
Got it.
And it's been like super, it's been a really good experience.
I'm sure. So talking about your background, you have a very interesting background. You worked in project management. Then as a founder, you created Prodcast company. You were founder there. Then you've also worked as a software engineer. Could you tell us where did deep learning start to come into the picture for you, and what made you pick this as an interest of you?
Yeah, so back in 2005, actually, I was in Polytechnique, which is an engineering school in France.
Okay.
I was I was majoring in computer science. Obviously, machine learning was not a huge field in 2005, just because like it was not working well. Like the computation was not there, the new techniques were not there, and it was mostly seen as kind of like a toy set of methods to kind of brute force other issue.
Even no Python libraries would have existed, I think, then pandas, matplotlib, anything literally.
Yeah, but you need to know something about French engineering schools is that like the professors are usually driven by theoretical computer science backgrounds. So what they really want to work on is kind of like algorithms. How do you prove that this algorithm is the most efficient way of resolving this issue? And basically that's kind of like the exact opposite of to machine learning, which is kind of, okay, let's try to approximate this function, and we don't really know why it works, but at the end we are going to have something that kind of works, right?
Yeah.
So yeah, like machine learning was definitely not a huge field, but I was still with a friend of mine. We were still like kind of trying to apply like really small neural nets to like virtual robotics competitions, things like that. So I was kind of doing like really small neural nets, but it was not working that well.
Mm-hmm.
So basically, I did a lot of like software engineering over the next couple of years, doing kind of like mobile apps, things like that. And in 2015, I was like, as I said, I was super interested in text processing. So I dived more into machine learning, and I kind of like took a few online classes, and because I really wanted to see what machine learning had become in the 8 years since I last looked at it. Mm-hmm. And yeah, basically that's why I was in 2015, and I was like super excited about like the new things happening in machine learning, and yeah, basically.
So I was going through your profiles, and please help me understand. You have, I think, about 1,700 contributions on GitHub to different repositories. You published a bunch of papers in the recent years, and you're also working on a startup. So what all activities are you handling, and what does a day in your life currently look like?
So I'm the CTO of the company. So in the company, everyone is pretty much like really experienced, both with machine learning and with software engineering at the same time, which is like not that usual, because you sometimes find people who are like really into science and machine learning, but who are not that great at actually coding things and having systems that work for a long period of time, like even deploying models into production and things like that. So we try to build like a kind of a homogeneous team of people who are like really good at both machine learning and software engineering.
Got it.
Which also implies that I basically work with the team, with the technical team. But everyone is pretty much autonomous and like self-driven. So what I'm doing is I kind of help the team working on a few different projects, but kind of like change projects over time, every like couple of weeks or couple of months, which is like something that really fits my way of working on technical subjects.
Got it. So in all of the projects that Hugging Face is currently working on, you have some sort of contribution there?
Yeah, I try to. Yeah.
Got it. To talk more about Hugging Face, you have just raised just north of $5 million US. Can you tell us how will that play a role in your future? Will you focus a huge amount of that into research, pushing the science, or what are your future plans like, and what rearrangements did you have to do after raising the seed investment?
Yeah, so we were super lucky because we found investors who were a super good match to our vision, which is, let's not try to find a monetized business application just yet. Let's just focus on the growth. Let's just focus on kind of pushing the state of the art in NLP.
Yeah.
And then if we manage to create something valuable, we find ways to monetize at some point in a way that's consistent with our like ethical vision and like the vision of like NLP as a whole. So yeah, we were super lucky to have them. It gives us some time to really push our subjects and push NLP, which is great.
Because essentially you're also solving a scientific problem along with a business problem. So I think science is the major factor there.
Exactly. Yeah, exactly. The way we describe the company is consumer science.
Okay.
Basically, let's try to push the science in the field of machine learning, and at the same time see how we can unlock some like consumer usages at the same time. So yeah.
Got it. Now I really need some help understanding about the projects and open source ideas, because there's a lot going on here. Maybe you can talk one by one, but to mention all of them at once, you have a live demo of a transformer OpenAI GPT-2 model running in the browser. You have a demo website of a conversational AI, a co-reference demo, again running in the browser completely, an open source library implementation of transformers with more than 10,000 stars on GitHub. Could you help us understand and maybe break down how these projects are being run? Because I was reading up, and I think the team is just between 10 and 15 members.
Yeah, it is.
So maybe let's start with the browser transformer model.
Yeah, so so we've seen over the last year basically that large transformers language models are a really important breakthroughs in NLP. Basically, it unlocks a lot of like super interesting things, and I think that we are just getting started in like discovering new applications and new ways of optimizing large language models in NLP, and seeing how we can use them to do like incredible things. So the two, like I would say, the two most game-changing transformers model last year were GPT-2 from OpenAI and BERT from Google AI. Both of them were initially implemented by the researchers in TensorFlow. And so like the like pretty naturally we wanted to use them in our technical stack, which is more PyTorch based.
Interesting.
So Thomas Wolf, who is our chief science officer, he kind of like took a week off to really sprint and kind of port BERT and GPT-2 to PyTorch. It was an incredible feat. It was like a really, really exciting project, and we saw that it was doable to implement them in PyTorch.
For context, even though they do mention sometimes, but there's no right mapping of porting one model from one framework to another.
Yeah. Basically, you like you see that there is always like some kind of like inconsistencies in the implementations. It's not really related to PyTorch versus TensorFlow, but it's more like about kind of homogenizing, uniformizing the way different researchers go about things, like diverse things such as like initializations, inference, like global like model architecture, training methods, evaluation, things like that. So it's not like, it's usually not the model itself, but it's all the different parts around it in kind of like the machine learning setting that are kind of hard to homogenize. So basically that was the start of our library PyTorch transformers, which kind of became over time and pretty quickly actually kind of a repository of large transformer models. Which is why we decided to rename it to PyTorch transformers. And as you said, it's been like really popular. It has more than 10,000 stars on GitHub. But more importantly, people use the library to use pre-trained models, and they download more than I think 20,000 different models a day, which is pretty massive. Yeah.
Okay, that's insane.
Yeah, that's really massive. So it's been a super exciting experience, and we plan on continuing to develop the library, and we have like lots of ideas on how to improve it and how to make it like easier and easier for both researchers and developers to use state-of-the-art NLP methods. So that's basically the vision for the library.
Got it. Now, I also want to talk about, you mentioned PiThoughts. So I'm definitely a PiThoughts fan because I come from a fast AI community. So I learned all about PiThoughts. But another thing that I read on Twitter is one of your models, it was very well engineered. The complete code was just under 500 lines, and the inference training, everything just in 3 files under 500 lines. So could you talk a bit more about what efforts do you put in there, and what made you pick PyTorch over TensorFlow for, I assume, even your internal purposes?
Yeah, so our goal is to make it so that it's really easy for both developers and researchers to understand new models.
Yeah.
So one of the goals is that the architecture is pretty easy and self-contained. Mm-hmm. So you don't have to read through like hundreds of pages of documentation or hundreds of files of code to understand what's happening. You can basically, things are pretty self-contained, and it's one of our philosophical goals in this project, is that it's super easy to kind of get on board and start actually both using the models and then kind of start tweaking the models, see how you can change like different training parameters and see if you can get to beat the state of the art. So that's kind of like really exciting, is that our library is used by researchers to unlock new methods and to discover new state of the art. It's not just a way to like kind of a downwards way of using a new state of the art method, but it's also a tool to find
build on top of it.
Yeah, exactly.
That keeps amazing me totally is this is a company, a VC funded company that's trying to push public research, so research that everyone is currently using. So I keep getting blown away by that fact.
Yeah.
Now to talk about the second project is a conversational AI demo that runs in the browser. So this is different from the app that you ship. Could you talk more about that?
Yeah, so we built that, and Thomas Wolf again was leading this project. We decided to participate in a competition last year at NeurIPS, the NeurIPS machine learning conference.
Yeah.
The competition was called ConvAI, Conversational AI Challenge, and was organized with the support of Facebook AI. The goal was to build an end-to-end conversation system that was trained on a data set of conversation called persona chat. And so what we tried to do, and we actually won the automated evaluation part of the competition. What we tried to do is we tried to apply the GPT model to conversation.
Interesting.
So basically, it was a really innovative way of trying to solve conversation by using a large pre-trained language model and use it to generate conversation.
Got it. I'm also curious, like, what's going on in the background. So, for example, and how is this being put into a website for both the problems for the transformer? What's happening in the background when I'm trying to generate a sentence, and same for the conversational AI?
So the demos that we shipped, they are web-based demos, but the computation is actually happening on a server. Just because it's not doable right now to do GPT-2 scale computation directly in the user's browser.
Yeah.
The model is simply too big, and you mostly need a server with either a GPU or a really big CPU to be able to answer your request within a reasonable amount of time, which would be compatible with like the UX that we want to provide the user. Right. So basically what's happening is that we kind of like tweak PyTorch transformers a little to enable either autocompletion in the case of like transformer.huggingface.co or conversation in the case of our conversation demo.
Got it. I also really love the beautiful UI that you just mentioned. So could you maybe speak a bit about what efforts did you put in there when connecting the UI with the server that it talks to?
Yeah, definitely. So to stick with the example of write with transformer, it was actually a demo that we wanted to do for a really long time. Basically, like for the last couple of years, like for more than 2 years, we've been wanting to do a demo with autocompletion.
That would have been your original vision of the app, maybe, I assume?
It was not the original vision, but it was something that we've been wanting to do for a super long time.
Got it.
But the language models, like the generative capacity of the language models before GPT-2 were not that great. So you could use like, there was a really nice project called AWD-LSTM by Stephen Merity. Yeah, it was a really nice implementation of a state-of-the-art language model. Probably 2 years ago, about 2 years ago. And we tried to use it to do a generative interface and to enable kind of like an autocomplete, but it was not working well enough that the experience was super good. Now, when we saw GPT-2 was out and we saw like it was really good at like generating text, that's when we saw, yeah, this is going to be a really, really nice language model to try and do something great on the UX side. And I should also mention that it's a work that was inspired by this project called Talk to Transformer.
Yeah.
Which was more like kind of like a one-off, like you start typing a paragraph and then the model autocompletes. But so it was a really, really nice project. We loved it. Yeah. It's been coded by a great developer called Adam King. It's really nice. But what we wanted to experiment with was something a bit more iterative, where you could kind of like trigger an autocomplete, but then also kind of tweak the text and modify it and complete it manually, and then kind of like, yeah, trigger the NLP model more iteratively in a kind of human in the loop way.
Makes complete sense.
Yeah, that's why we really wanted to push like this kind of UX, and we've been like super happy with the way people have been using it. We've had more than 100,000 users on this web app. So yeah, it's been super interesting to see how people use it to either write. They can write like fiction, like fun, really fun, weird stuff, but also use it in a more serious setting. Kind of, we've seen students using the app for essays, stuff like that. So yeah, it's really impressive the different ways you can use the technology.
Got it. Now coming to the open source side of things, so back to the PiThoughts-transformers GitHub repo, could you tell us more about what all transformers live in there, and how did you manage to put all of these as open source projects? Because transformers usually are in TensorFlow because they train better on TPU pods, so they usually train it on TensorFlow.
Yeah, so I would say today GPT-2 and BERT are the most popular transformers that we have.
Okay.
On the repo, and both of them, like together, they probably account for like 2/3 of the downloads of the model downloads that we have.
Interesting.
But yeah, we also have an implementation of ExcelNet from Google, and from and an implementation of that we've shipped pretty recently, like less than a month ago, of Roberta from Facebook.
Mm-hmm.
Facebook AI. Roberta is basically a careful pre-training optimization of BERT. So it's really close to BERT with a few differences. But we've seen a lot of interest for Roberta over the last couple of weeks. So we think that it's going to be pretty popular in the next couple of months.
Mm-hmm.
And yesterday, actually, we released a new model called DistillBERT. Yeah. And it's a project that's being led by Victor San from our team, who's a really great research scientist on our team. What DistillBERT is about, so DistillBERT is basically a shortcut for a distilled version of BERT. And distillation is the process in which you train a smaller neural net to kind of replicate the output of a larger neural net. Mm-hmm. So what Victor has done is shrunk the BERT model by 50% while keeping, I think, close to 95 or 96% of the accuracy of BERT, of the original BERT. On a downstream task.
That's really amazing. To pause you for a second for some context to the audience, could you help us understand what resources does one need to be properly able to play around with BERT and then with DistillBERT?
Yeah. So basically, BERT, to use it in production, you either need a GPU-based server, or which is obviously more pricey than a GPU-based server, especially if you ship it into a product that has to have a certain scale, like a certain volume of number of requests per minute or something like that. What DistillBERT is enabling is kind of a method to, while keeping most of the same output accuracy, enable people to deploy to way smaller CPUs, mm-hmm. or with the same latency, or to shrink the latency. If you keep the same kind of servers, you're able to run like larger volumes of requests and have them served in a way less time. So yeah, basically it's a method to optimize BERT-like models for production.
Got it. To talk more about this transformer requirement, what are your thoughts on, for example, your Hugging Face is pushing in this direction, but to push the state of the art in NLP, do you really need now unavoidably a huge cluster of GPU, or how can a person with a small cluster or maybe a single GPU push the state of the art?
Yeah, so I think definitely you don't need like really large clusters of GPUs. If you have access to really large clusters of GPUs, and by really large, I mean like maybe 1,000. It's certainly interesting to have access to this kind of compute, but it's probably going to gear you towards research that's kind of biased by the amount of GPUs that you have access to. So you're probably going to compete with like the big tech companies on like kind of like, I would say, computing driven machine learning research. Whereas there is also a lot of interesting research to do in the field of like more more resource constrained machine learning. At the same time, like having a pretty good GPU is like at least like 1 or 2 GPUs is doable. There are ways to also get access to like credits from the cloud computing providers to have access to a couple of GPUs. And it's like you can already do a lot of like interesting things with a couple of GPUs. So I would say that it's not a super like it's interesting to have access to a lot of GPUs. I'm not going to say the opposite, but you can also work on really interesting things with a small number of GPUs.
For sure. So I think what you're suggesting is if you have a single or maybe 2 GPU, use them for prototyping. And then for a few lesser credits, once you have the optimal solution, just try running it with a broader server and see what direction does that lead to.
Yeah, definitely. Yeah, that's a good approach.
Got it. Now to talk about the crazy speed at which models are shipped. So there's also a small repo that lives inside of the transformer repo, which in itself is amazing, is the Swift repository where you ship these things onto an iPhone. First, I'd also really like to know, so we were just talking about these things need either a GPU or a heavy server, a heavy CPU. How can these monstrous models run on a small iPhone?
Yeah, so so the thing is on iPhone specifically, the hardware is actually pretty good, right? Like the GPU that's in an iPhone is competitive to a small GPU that you can find on a laptop, right?
Okay. I wasn't aware of that.
Yeah, that's pretty interesting. And in the most recent versions of iPhone, they actually have a dedicated chipset for machine learning, which they call the neural engine, which used to not be accessible by third-party developers. It was only used in previous versions of the OS for native Apple apps. But now you get to access the neural engine. And for instance, for computer vision related tasks, you can get a huge boost in performance using it. So I would say that the most recent mobile devices are really good platforms are going to be good platforms in the future for what we call edge machine learning. So not doing machine learning on servers, but doing machine learning directly on the user's device, which can be good for both like performance reasons, budget reasons, and also for to develop kind of like privacy first services, because the less data you need on the server, the less risks of kind of data leaks or unethical approaches you're going to have.
For sure.
So basically what we try so Apple, first of all, they used our PiThoughts transformer repository to train a model that they then showcase at WWDC conference this year. So we were really excited because when Apple uses your open source, it's really good validation for what you're doing. And then we ported GPT-2 as well. GPT-2 was interesting because we started by converting the small model of GPT-2, but it was already kind of too big for an iPhone. Like you needed the latest iPhone or an iPad Pro to actually run it to the generation. It was pretty fast when it managed to work. So the bottleneck was more at the memory constraint. Like it was using a lot of memory because like the network itself, the weights themselves are really large. So the bottleneck was more on the memory side of things.
iPhone and iPads just have 3 to 4 gigabits of memory, I think.
Yeah. And like one particular app is only like constrained to a small fraction of that memory. So you cannot just use all the system's memory. So you're basically constrained to maybe 1 gigabyte or 2 gigabytes at most. But what we've managed to do is kind of like slim down the GPT-2 model to a point where we were able to run it on the most recent versions of iPhone.
Okay.
So yeah, it's an interesting project. The vision is that, as I was saying, we think that at some point, more and more machine learning is going to happen on the edge for a bunch of reasons. So yeah, it's a good, even though it's hard today to really productize machine learning models on the edge, on devices. We still like investing time in trying to push that subject as well.
What efforts do you have to go through when like porting these models onto an iPhone? So it definitely isn't an easy job. What challenges do you face when working on that?
Yeah, so Apple has their own kind of like machine learning intermediate representation system called Core ML. Which is kind of similar to Onyx, if you've heard of Onyx, ONNX, which is kind of like a format for production optimized neural nets. So Core ML is really close conceptually to Onyx, and basically you have to kind of remap your PyTorch model to a Core ML model. Which is kind of tedious at time, but it's not super hard.
Got it. I think would also love to know your points, but this would definitely push into the direction of privacy. So people are always concerned when you're talking to models. The recent issues in Europe happened. What are your thoughts in there? So because Hugging Face does ship a app that talks to an API. So how do you think of privacy there, and what are your thoughts around that topic?
Yeah, so we are pretty serious about, first of all, protecting the user's data. So we encrypt each user's data on the server and try to secure that data at the most efficient way. Each user's data is obviously in a separate silo. You're not going to be able to get someone else's data just by talking to a conversational AI, which shouldn't happen. And more like kind of on a higher level, we discussed the subject of like AI ethics over the last couple of years. We wrote a blog post about what we think some important AI values for AI first companies should be. And so it's a subject that we are thinking about, and that we think is going to be increasingly important in the future.
So when we use the app, because I'd love to know what data sets you use. So for conversation, GPT-2 is trained on Wikipedia, and a normal chat conversation doesn't look like Wikipedia. So you train on the user's data, or what? How has that model been trained?
Yeah, so we train on a number of different data sets of conversation. So I was mentioning the persona chat data set, which was put together a year ago. It's a small data set. So you're not able to find today like really large data sets of conversation. But using transfer learning, you can still leverage smaller data sets of conversation. And we have our own data sets of conversation that we use as well. And using transfer learning is a good way of being efficient even with smaller data sets.
To talk more about research, so maybe Distilbert would be a good example, but you have published a lot of great results in top conferences. What research projects are you excited about, and how does your team pick a theme that they want to work upon?
Yeah, so right now, everyone working on, like, all the researchers working on like large transformer or large language models. We're trying to kind of like seeing what we can do to help them, and it's really interesting subjects. Yeah, like more precisely, I've been like personally super interested in like conditional language generation, conditional text generation over the last couple of months. It's something that I think is going to be super interesting in the next year.
So what's the difference between conditional generation versus normal generation? What happens?
Yeah, so basically, so to take the example of GPT-2, for instance, you kind of like seed the text generation with a small paragraph.
Yeah.
But it's basically the only control that you have on the generated text. So what if you could also input at the same time like a structured data point, such as like maybe emotion? What should the generated text emotion look like? What should the generated texts like kind of language look like? Should it be like familiar language? Should it be like a really serious text? Things like that. Yeah, way to kind of like condition the generated text. Another example is basically code. Like you can already kind of use GPT-2 to output code. If you start typing like HTML or JavaScript or Python, you get GPT-2 to actually output Python code. But the thing is, it's not always valid code. So what if you could add the constraint that the Python code has to be valid, or the C++ code has to compile, the LaTeX source code has to actually be valid LaTeX code as well, things like that.
So you're aiming to replace a researcher and also a programmer by doing that?
Yeah.
That's pretty scary, but also interesting. Could you maybe also talk a bit more about Distilbert? So the open source version is already out. Can we test it out? And do you plan on releasing it on the iPhone as well?
Yeah. So it's something that we've been thinking about. Someone has called the work that we've done on Distilbert the NLP equivalent of MobileNet.
Okay.
Yeah, so MobileNet in computer vision is a set of techniques that people use to run like ImageNet, train large computer vision models on small mobile devices. So if we manage to create something that's kind of like similar to MobileNet, it would be like super interested. The thing is with Distilbert, yeah, like mobile devices are important, but even like on servers, it's going to be, I think, like super popular because a lot of systems, a lot of services, it's going to enable them to use large transformer models in production, because it used to be like too slow, or it used to require GPU servers. And now with Distilbert, you're going to be able to do it on like a regular server on like AWS or Google. It's going to be like it's going to be way easier to deploy state-of-the-art NLP into production. So which is something that we are really, really excited about.
Could you also tell like how much of efforts in terms of maybe months or person went into this? So I think there are only a few collaborators on the project.
Yeah, so basically Victor, San, Thomas Wolf, and Lysander Debu have been working on the project for maybe a couple of months. Yeah.
Got it. Would you also be pushing into this direction? So again, this is an interesting direction of building transformers that use lesser resources, again going towards the MobileNet side of things, or what current research are you excited about?
Yeah, I'm super interested in the field in this subject. Like other ways of making it easier for developers and researchers to build on top of like state-of-the-art research and to push state-of-the-art research and to use it in production at scale is basically the thing that I'm most interested about.
Got it. To talk more about how did you learn these techniques? So I found an older blog post where you were putting out an invite for, I think, the 2 to 4N course. So what are your thoughts about your current favorite online courses maybe, and which ones did you personally go through while you were picking up these techniques?
Yeah, so basically when we were like really diving into NLP 3 years ago, we found the Stanford class, which was taught by Richard Socher at the time.
Yeah.
So it's called CS224N. It was a really good way of kind of like putting a small study group together and going through the videos, going through the exercises, and kind of like keeping ourselves like really motivated and doing a lot of things in a short amount of time. So it was a really good way of kind of like diving into the subject. I really recommend it. It's a good class. You can find like newer versions of the videos. In the recent years, it's been taught by Professor Manning from Stanford. The content is really good. It takes a lot of time, obviously, because it's such an advanced class. It's taken by basically Stanford PhDs, so it's a good class. It has to be a good class, right?
Yeah.
But it's a good way, I would say, to really dive into NLP. The second thing I definitely recommend is fast AI. You were mentioning it. I think it's a really good class, and they're doing like the fast AI team is doing a really good job at having a new generation of NLP researchers or machine learning practitioners into the field. So it's really good content as well.
For the viewers who don't know, so FastAI usually is famous for its 2 deep learning courses. There's also an NLP course that they recently put out. So I've just completed watching it. Do check it out. It has a lot of interesting stuff. To talk more about transformers, because back when I scrolled through 2 to 4, and I don't think it covered these topics. So how do you personally, when something new comes out, go through it, or how do you pick up these techniques personally?
Yeah, so the really good thing about having such an experienced team as we have is that like everyone in the team is proficient and kind of like following what's happening in the field. So it makes being on top of like new things way easier, because we just basically talk about like new papers every day, right? Every day we like Twitter is a really good tool to find out about new techniques, new models, and basically being a team is a really good way to finding that out. I didn't mention it, but we are based in New York. So most of the team is in New York. We have a few people in Europe as well, but most of the team is in Europe. And I'm a really strong proponent of being in the same place and kind of like having conversations, like impromptu conversations about new papers, new techniques. Makes it like super easy to to learn about new things, which is a really good setup.
Got it. Before we conclude the conversation, so this was an amazing insight into all things Hugging Face is doing. Thanks for that. But what best advice would you have for people who are just starting their journey and want to work in this intersection of NLP and conversational AI?
Yeah, so my advice would be just take the leap, right? Just if you're passionate about the subject, just start studying, just start. So I really like to learn by doing. So I would advise to find something to do, like maybe a small open source contribution. Open source is a great way to learn, because you're learning kind of like from the bottom up, from the implementations. It's super natural to dive more into the theoretical part of machine learning once you've kind of see how things are actually working on the implementation side. So yeah, I would definitely, my advice would be take the leap and start doing some open source contributions.
Got it. Do you have any
PiThoughts Transformer, our repository, is a good way for that, because we try to be like really welcoming to first-time contributors. So I would advise, why not have a look at PiThoughts Transformers?
I was just asking you about that. So what are the low-hanging fruits? For example, a newbie who's coming to your repo, where should they start or contribute to?
Yeah, so we try to give indications to users in the GitHub issues. We have a lot of fields that would be like not super hard to dive in, but that would be super interested. Also because like we have a set of different usage examples. So for instance, you can use our libraries to fine tune on a different set of NLP tasks, such as like squad, glue, something like that. So finding like a script, an example script to fine tune on a new task, or to improve the way we fine tune on an existing task, are like pretty easy ways and efficient ways to dive into the library.
Got it. Thanks for that amazing advice and all the amazing things. Before we end the call, could you maybe tell a few platforms where we could follow you and your work? What would be the best platforms?
Yeah, definitely. So the Twitter Hugging Face account is a really good way to keep in touch. So it's twitter.com/huggingface. Or we try to publish a lot of things on Medium as well. Hugging Face on Medium. And of course our GitHub page and GitHub repos, which are like a good community directions for us.
Got it. We'll have all of those linked. What about your profiles? Where can we follow your work, your personal profile?
Yes, so I'm Julien_C on Twitter. You can follow me on Twitter and send me a tweet.
Okay, got it. Thank you so much, Julien, for joining me today, and thank you for all the amazing efforts in the open source and research direction from Hugging Face.
Thank you so much, and let's keep in touch.
For sure. Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review, or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.